the next part of our waves discussion. What we're going to talk about is um, diffraction. Okay, that's when a wave bends through an opening or around a barrier. And then we're going to talk about Young's double slit. So what we have here is a light generator that will generate parallel or plane waves towards this barrier. And then you'll see that the barrier has this effect where it starts to curve out, Huygens principle as it's called. And there's a couple things we can deal with. So first we can change the slit size. So we can make the slit really, really small. And you'll see as we do that, it starts to define these rings a little bit nicer. And as we make the slit longer, we start to get these flatter wave fronts. And if we throw our screen and intensity in there, you can see that it really only hits at one point. And over here, you're getting this decay, this odd looking shape. And as we bring this slit in, okay, it gives you a really defined system here, but a very spread out or diffuse light. And so we're going to take our electric field sensor, right? And you can see, well, one thing I want you to notice first is the wavelength does not change, right? The wavelength is the same over here and the same over here. And ideally, the slit should be about the same size or smaller. Okay, smaller than the wavelength gives you more defined output. So what I'm going to do is I'm going to place dark gray sensor in the middle, light gray sensor off to the side, and you can see they're off just a slight bit, but the intensity, okay, the amplitude of this electric field is much stronger down the center than it is off to the side. So there actually is some loss. As you move away, you can see that that loss gets greater until it's eventually nil. Now, a couple things you can do, right? You can change the frequency. If you change the frequency, it'll change the spacing of the waves outside. And likewise, you can increase the frequency, you'll get the same outcome. Now, something interesting about this is this happens for waves. So this caused a lot of interesting ideas because for the longest time, they thought that light were particles, right? Photons. So if you have an opening, they should go through the opening and then they should hit this screen over here. Now, what they found was something that looked more like this. Switch the frequency to green, it's just easier. They saw this pattern arise, okay, that we saw earlier when you have two point sources interfering. In the last video, we saw this. And you can see that we're getting a pattern just like that. In fact, you have a level of high, okay, or a level of strong intensity and a level of almost no intensity. Right, you can see this light gray one is getting nearly nothing. Okay, there you go. It is getting nothing right there. But one thing that you can notice is as you move across, and it's a little jumpy, but as you move across, if you look at our graph there, the amplitude will increase and then it will decrease and then it will increase and then it will decrease. And just like the interference patterns we looked at before, that's why you're seeing this. Now let's see if we can increase this, or rather make this a little more prevalent. All right. As the slits get closer together, you can see that this is a bit brighter than the outsides. So what I'll actually do is let's increase the frequency. This should define it better for us. You can see this inside tends to be a little bit brighter. And what we call this is actually the central or the zeroth fringe. Okay, this is a fringe. This is your first order, and then you have your second order, and so on. And the fringe is caused by the interference of these waves, right? So the fringe is where you have the constructive interference and you have these destructive spots. Now, this was a huge deal because this can only happen if light is a wave, right? So Young's double slit experiment showed that light really, really, really had to be a wave. However, the photoelectric effect, right, showed that light had to be a particle. And that's where this wave particle duality really stems from, is from that idea that both of these are true, depending how you observe this. Right, again, we can change the frequency, just see what this does, and you'll notice that it changes, okay, the distance between the first max, or the zeroth maximum and the first order, this bright part. All right, and if we change the slit separation, that will also change how our pattern looks. You move them further apart, and look, now we have more, okay, more of these fringes within our span, and we can really just move them as far away as possible. And you can see, but you can also see as we change the slit length, that will also change how we visualize this. In fact, if you make the slit length too open, you're not actually going to see the effect that we're thinking of. You can open it all the way and the light wave passes right through. It's really the constriction of this, creating this double point source, that is what gives rise to this pattern and the idea that, it's an electric and magnetic wave. All right.